Okay. It's almost done. I wish I can able to finish this class.
One left.
One left. So because I'm not feeling well for this week, and also slightly headache. I don't know why.
I'm sorry.
I
Last one.
I wish I can complete. At least one thing I want to cover in the lab, because you need to learn this one, and you need to do it for your assignment. So it's about the tag-log avoidance, if you remember. Okay, so I think almost so far I think it's this all for the class. So I wish I can insist. I can able to complete at least for this part. Okay, and we speak. True. Okay. Okay, so I think it's last week I jumped this part quickly because I want to cover in the lab. So showing like all the steps. So this one is called the for the deadlock avoidance. So this algorithm is called the banker. So when you say banker, okay. So if you are the banker, like you come here and then I need to check like how much money I have, like cash I have, and then I need to know let's say I have $10 right now. If you come here, you want to get 5. Then I can check, okay, I have 10, I can give you 5, right? If you come here, if you want to get 40, but I only have $10, then I cannot give you. I say, okay, sorry, I cannot offer this one. So you can go back to the queue and wait over there. Once I will come back to serve you once I maybe get another one. So maybe somebody come to deposit the money. That means like if we in actual situation for the OS, once the process complete and release all those resources and I get the money back, like that means I get the deposit, get the money. So once your process come back and then, okay, why now somebody deposit 150. So why now I've total I have 160. Then after you come back, then I can like give you $40 like this. Okay. So here's the idea of the banker algorithm. And for the banker algorithm, I skip pretty fast. So far the structure is like we have a stage we need to determine. You will receive a question. For practice, if you want, you can like put the notes and draw. And if I give you an assignment, you need to tell me like showing step by step. Okay, so how can we do that? I will in the beginning, I will start with allocation, max, and available. So far, like what's the allocated, and then what's the maximum required, and then in current, here's the banker. Okay, so what's the available resources right now? Okay. And when I want to like determine the final state, is it safe? Okay, and then where's the deadlock? So if we have the unsafe state, and the deadlock always stay in the unsafe state, right? So we need to figure out. If I ask a question, okay, for this process, like for this situation, can you tell me it's a safe state or it's unsafe? We're going to occur the deadlock. Okay. For the first step, if I give you a table right here, so we need to create a new table or a new matrix. Okay. So that one's like the max minus available, the allocation, that one. So we will create a one is called the need. I think I have a typo allocation. Okay, so we create another. Okay, so how can we do that? Is like you right now we will see the max table, right? So maximum right now we have like 0012, and then 1750, and then 2356, and then P3. Process 3, like for resource 1, R2, R3, R4, so it would be 0652, and then P4, process 4, we got like resource R1 to 4 will be 065, 56. Okay. So I will give this table to you. Okay.
And that is
Mhm.
the resources available to each.
The maximum they request. Okay, so the max. Okay, so first we look at the max right now. Okay, and then we look at the allocation. So the allocation, okay, so far will be like how many already allocated. Okay, then we need to know, okay, allocation is the current stage. How many resources I allocate to this process. So just like two metrics, metrics, if you refer to the matrix table, so right here. But I just like not going through the details one by one. So I tell you the process, like how can we calculate. As a first step, so you can see, and then the allocation right now for process P0. P0 will be 0012, and then P1 1000, and then P2 1354, P3 0632, P4 0014. Okay, so two tables right here. And step 1, we need to minus the matrix. And then you can put the need table. Okay, that's what the resource we need right now for the matrix. So you can copy the structure from P process 0 to P4. So total 5 processes, and then we have 4 resources: R1 to R2, R3, R4. Okay. So for the P0, first one, maximum minus allocation. So 0 minus 0. So R1 and R2, they're all 0. It's easy. And then R3 will be 1 minus 1, 0. R4, 2 minus 2, 0. Okay. So that means for P0, I do not require any resources anymore. Okay. And then P1. P1, R1 will be, I have maximum, I just need 1, and I already allocate 1. So 1 minus 1 is 0. And then R2 will be 7 minus 0. So I still need 7. Okay. And R3, we have P2 5 minus, yeah. Okay, we're talking about P1, right? Something I lost. Am I talking P1? Okay, thank you. Okay. We're talking about P1, so 5 minus 0, so it's 5, and then R4 will be 0 minus 0, so 0. Okay, so so P1's done, and P2 will be 2 minus 1, 1, 0. We have 3 and then minus 3, so still 0, and then we never have a net negative. Suppose we shouldn't have a negative comes out. Yeah, we grant all those necessary. Okay, and then P2 R3 with 5 minus 5 will be 0, and then 2. Here's like 6 minus 4 will be 2. Okay, and then P3, and I just minus it. I just like jump quickly. So 5 minus 3, 2, 2 minus 2, 0. Okay, and P4. So we're here 6 minus 0, 6, and 5 minus 1. Typo. P4 minus here's will be 4, and then 6 minus 2 will be 2. Okay, so the table will be like this. So your step 1 is ready. Okay. So after we create a need table, and then we will check. Okay, I will see. Start with the P0. So just like sequentially. And when we look at sequential, okay, so right now I will check the available right here. Available right here, R1, R2, R3, R4 will be 1520. And then when I check the P1, so P0, I just all zero, so all clear. So I will put the a list for P0 right here, and so finish. So you need to tell me, okay, P0 is done. So it's the first item. Okay. So after P0 complete, so what's the new available? Of course, like you can change the name. I name it available, or if you want to sometimes we call it a work. So either one of the name. So why not like working right now? So it's the same table. It's called available. So right now available is 1520. Okay, and after we execute, okay, the allocation right here. Well, how much we release 1 and 2. R3 will be 1 and R4 will be 2, right? So I add with the available. So 1534. 32. Okay. So here's the P1 after we execute, right? P0. Okay. And then next we need to check for P1. For P1, what's the required or needed resources? 0750, right? Okay, and then look at our available. Do we have available resources for P1? No, so we just put on hold. Okay, just wait. So let's say I need to check the P1 and then P1 available right here. So I did nothing. Then we will go to jump to P3. Okay. So the list right now is still P0, only one P0. So not yet finished is like for the P1. Okay, for the P3. Oh no, P2. Okay, P2. P2, we require 1002. Do we have enough resources for P2? Yes. So yes, then I will for available is that help me to read it. Okay, so I just put it right here. And then if you want to working on it, so you can just put it right here. So finish. So P2 finish. So where's the new available? After we complete P2.
Yeah, subtract away what P2 or how do you find that?
P2. Yeah, we are adding. Yeah. So what the allocation, right? We assign to P2. So we are at 1354. Okay. So 1354. So right here. So 1, 3, 5, 4. Okay. So here's the new availability. Okay. So after we check P3 and then P4. Because oh yes. Oh yes. Why that's why I skip quickly. Okay. Okay. Why now I'm not in a condition? So you can. Okay. Okay, this one we assume is good the round robin. So taking times P0 to P4, and then after we complete, we go back to the remaining. So we go back to P2 after we finish P4. So if let's say right now I already finished P4. Okay, so I assume in this moment because it asked the question. So I finished P0 and P2, and then I just check. Okay, P4 I still not able. Then I will go back to P1. Okay, and check. So is my resources right now is available for P1? If yes, then do the same. If no, jump to P3 and check again. Okay. So if you checking like in this status, we never able to get it. So what's the status? It's unsafe data. Okay, yeah. So then you can conclude, okay, so in this moment, let's say if you cannot like get it returned, then you can just the result is the unsafe just like tell me it's unsafe state. Yeah, and deadlock. You can tell me it's deadlock. Okay, so it's the deadlock. Okay. So you can conclude the solution in this way. Okay, so but of course we are not yet complete. So let's finish it. Okay, so right now we need to check the P3. So right now the availability is at 2886. We need to check our need table. Let me copy this one so it's easy to get it. I put it right here. Okay. So for P3, do we have enough resources for P3? Yes. So we can put it right here, P3. Okay. And we just need to add the allocate, because once we have enough resources for P3, that means we can execute and compete. So once P3 complete the processing, then we can release the allocated resources to it. So what's the total allocation? Right here will be 6 P3 0632. Okay. 0632. Okay. So here's the new resources. Okay. And then P4. How about P4? 642. Do we have enough? Yes, we do have enough process. Then we can say, okay, then we can let P4 to finish it. And what's the allocation? Will be 1.4. Okay. Okay. So we have 1.4 to release it. Okay. Okay, so right now we compete from the first one, P0 to P4 already. Okay. And which one we still left? Okay. P1. Okay. Here's a step 4. Okay, then we go back to P1. Okay. Fine, and then go back to P1. Okay. P1. What's the required process for P1 again? 7.5. For this time, can we allocate the resources to P1? Yes. So the sequence, yes, we are allowed P1, and just add the value back to the P1. P1 will be 7.5, right? No, here's the I need the allocation is P1 just 1. Okay, get it back. So so far right now we are execute all the process and then complete all the process. So what's the final state? Will be safe state. It's okay. Okay. So it's pretty easy for the banker, right? Okay. So if I give you the question, like you will have a assignment to doing like to answer this question. And also if in the exam, if you will see the question about like what's the deadlock avoidance of the banker algorithm, then you can showing the steps like this. Okay.
Or sorry, the max.
I will provide this. We already like we did, yeah, allocate to the surface. So it already taking 1. So that's why we have the minus the coordinate table. So like we mainly like how many resources do you need? Okay, so is it enough for us to execute, like to complete this process? Okay, for this assumption that in certain time equals to n. Okay, we never know what's this actually, but it's never time equals to 0. Okay.
So then we can do it. If the process has enough finishes then you add the max back to the available.
I mean, yeah, could you, why now I cannot focus?
Oh, yeah.
Back to how much you have, so you can use that for other.
Okay, okay, they can have you understand the question. Okay, yes, sir. And as I put it straightforward for the banker algorithm, so it's like for the question, I won't like say like some like give you nothing and then ask you to tell me what's the status, like is the safe or unsafe. So you will see the three tables I gave you. So two 2D metrics. Maybe I will change the is like resource, how many resources, like maybe 2, 3, 4, maybe a process I will getting more or less. Okay. And we have the allocation max and available. So it's the when the array, so it's like telling right now where's the available resources right now. Okay. And remember the first step, just need to get the need. The need, that means like minus it. After you calculate like get the need table, the matrix, then you can go through from the process, the first process to the last one. If you go through first one, and then if you couldn't finish all of them, you need to tell the sequence, like which process like going to compete. And you will go back, okay, and loop one more time. And if you can compete, that means like going out of SS and then compare all the process, that is a safe state. If you couldn't, like let's say if I never able to get the process, like go to the next one, then it's unsafe. We have a deadlock. Okay, just tell me the result. Of course, for some question, exam maybe I will let you you need to input it and tell me what's the stage. And do you have any question about this one? No. Okay, then I let you have some practice exercise. I couldn't speak. You actually have one more. Maybe I'll cover one more. Let you have an exercise. Okay, and we have the content, and I upload one is the, if you still remember the dining philosopher, the one I just like jump quickly, I will share the code. So you can because that one is the C purpose. Okay, maybe yes, it's a Python. I make a mistake. I say it's the wrong one. Okay. Okay, let me change it. Okay. Okay. If you download it. Okay. Yeah. Good, good, good. P1. Okay. Using P1. Okay. If you know for the situation when I start with I think. Okay, let me go back to the Okay. So for this problem, you will know like we have no two philosophers like can use the same fork. Okay. And then no philosopher must like starve to death. So we need to avoid the like deadlock and starvation. And because the reason because you already have a C+ file, so that's why I didn't give you like the C+ again, but you can like simulate to run it. Mainly is like we start with the think. Okay. So we similarly start with the thinking and then wait. And because we can apply different mechanism, we say that's a method, or like sometimes if you want to use the C rate C signal, also we can do it to avoid the diving. So here the same applying the same logic. So we have this philosopher. Here's like we have using the fork, and then we have the generate the left and right. So because like for the one table, you can like take the fork from your left hand side or one hand on the right hand side. So we can access. So every time we're taking terms, and then we have the left and right. So we pass the left and the right fork, and we check. okay, so when I get it, so every time I run by myself, I will think about it, okay. And then for thinking, I will see, okay, so myself thinking, and then I have a function sleeping, just like, okay, pretending for some process thinking time, like for taking certain action. So after I execute, and then I will run the function, like call the function like it. So for the it, I will see, okay, is it available for the left hand side? And if okay, and then how about the right hand side? Okay, so okay, then we have the critical section that we're taking certain action. And okay, so this one is just like for rating, just simulate. Okay, because for process we have some times, right? Because for this one, just one instruction, so it can compute within 1 nanosecond. So it's pretty fast. So we put the sleep to wait. So after we compute, then we need to like release, like put it down. Okay, that's like how it works. And for the same method, but you can try to execute and run it. And because they went without the safety logs, then you need to, maybe in the exercise, you need to complete the program. Okay. So right here, we will giving the same scenario. So for the class, we have the 13, create a different thread. So they will initialize with the name and to fork left and right. That's what you see. And then we try to execute a loop, and where the philosopher, like when they alternate with thinking and the eating. Okay. So in the thinking stage, so they will simulate. So we're thinking that we give a random time. So that's what we see the function we wait. And so they're not using any resources like way of thinking. So they're not taking their, no, they occupy. But when they start to eat, they need to okay. That means we need to grab the right, left, and right to do it. Okay. For the content manager, and then we will handle it. Okay. So we have to put a timer to simulate. For the fork function, so the forks will be create the child. Okay, so this one we create a multiple philosopher. Okay, because we are running same pieces of the code. Okay, so most of for OS you will see we try to create all the codes using the system call. So because they all of them will execute exactly the same instruction. So that's why we try to using the while loop, and then using the log or some a flag to make sure like only one process or only one child can able to get the key, and then to take action, like to do to run the critical session. Okay, so we have the main function. So for this solution, we still have a problem like calling the deadlock. And that's what you need to do, try to like implement. You already have a sample code. So you need to doing is like when they try to pick up their like left and the wait for infinite. So because like when you execute for this one, is it possible, right? When I have a multiple child, like let's say I have 5, when I try to get my left, and then I next code is I'll execute my right. But if let's say I have a process philosopher like 0 and process philosopher 1, philosopher 2, let's say like this, I make it pretty short. If P0 dot left, I already get the left. If I want the maybe for the P1, I already want the left, and then I want left, and then P1 dot right. Okay, so if I'm doing this way, if my instruction order, if we are doing this order, so we are always stuck. Okay, then how can we prevent the deadlock? So for our this one, maybe we need to maybe like the all numbers we also pick up their right false, so we can still doing it this way, or like concurrency, like when we have the third things. So are we allowed like think it concurrently? Okay, so if some others are doing like thinking, then only one can eat. Okay, So when they release it, so in next one thinking can pick up the brains to do it. Okay. So that's how can we, if this one we sometimes you hear turns color race condition, then so we are always like compete for it to get the range. Okay. And for the deadlock view, doing this one, then how can we modify this problem to prevent the deadlock? We can allow like maximum concurrency, and how can we do that? There could we share some idea or like how do you think for this like video software, like based on the description, how much you understand about this situation? Right here. Where's the okay, 5 table philosophy. Well, based on the just like ignore the one I gave you, because from the PowerPoint you already have the solution. And actually for all this situation, the problem, we always they have like we give you the solving solution. Okay, but when we discuss or try to understand for this one, let's say how can I avoid the order or like taking this one? If I grab the right for the left, then how can I make sure like no other philosopher to take my right before me? Well, it's possible, like, yeah.
So or do they all pick it up, try to pick up at the same time when it starts, right?
When we say pick up, you just because we are assuming start with the P0, yeah, P0 we can start it and then just run off the table, but it can be any time. But actually, I cannot say it's sequentially, because it's possible like if we are all like 5 people sitting on the table, okay, so it's like anybody when we are thinking, we just like sitting over there, right? We didn't pick up our fork like even left or right. Is it possible concurrently like 2 of you like pick up the fork in the same time? Yes, it's going to happen. So how can we avoid? Or like let's say most of the deadlock is like I already pick up either one of it. Let's say I'm the P0 or you're the one like you're 4 of you like sitting right here. You already pick up the left, and then he also pick up the left, but you need to grab the right, but he already grabbed the left. Then because your right is his left, right? To catch the problem or like anything. Okay. Or if you need to like really negotiate, like, okay, so 4 of you are like sitting on the table, and then right now you have a situation like this, then what kind of solution can you propose to avoid? Okay, if I grab the left, then how can I make sure like, because you have 2 states, one is thinking, one is eat. Okay, but if you want to eat, what do you need to do? You need to grab the fork. Yeah, okay.
Or either they try to eat first, and then you have the alternate word. It's like eating, thinking.
Well, the thinking period is a random amount of time. So each of them are gonna think for a random amount of time and then try to pick up the points.
Yeah.
And so we need to try to prevent, when they get to the end of that random amount of time, that I have access to the points.
Yeah, so as I said, or don't think about maybe when you are confused with the process. Okay, let's say if you right now for your table right now, 4 of you, okay, think about it. So you are just thinking, like most of the time you're just sitting and think. Okay, but if you want to eat, you need to grab it. Okay, left, and so we'll pick from the left first and then right. Okay, but is it possible that when you want to grab the left, also he also grab the left, right? Because you will check your left hand side first, right? So if you check your left, I grab it, and also you will grab the left. But when you check your right, he will grab it.
So what if you made it, you alternated which fork they check first? So if the first guy picks up the right fork, the guy next to him, his first fork would be check with the left fork. And that way he's never holding the other fork.
Then, okay, but here's the things. There we say the fork. Fork is the contrast. So it's the exactly same copy of the source code. So are you maybe, okay, so one of solution, okay, am I maybe checking my ID? Is an odd number, even number? Or like, how can, like, maybe I need to create two pieces of the code. Maybe I check my right hand, like for odd number. So as what you propose, like maybe two different code. So one is checking right first, one is checking left. Okay. And then about next. Okay, so if so one's checking left, one is checking right. Then, but you're still fighting for the right and the left, right?
You're still fighting for a fork, but you won't have a fork if you're not eating. So you can't. You would have to wait.
Okay, yeah. So how can you do? Okay, let's say I already grab my left, and you already grab your right. Okay, so we have one is available. Okay, then I give a hand think. If you couldn't grab it, are you still holding yours, or are you going to put it down?
Keep holding mine until that one down.
Yeah, because right now from the current one is that I already grabbing it, so I keep waiting for it. Yeah. That's what I'm asking. Okay, is because I say one of things like, is there possible solution? Yeah, if you can answer this question, then you may become so.
I don't think you should put the fork back down because you could keep going in an endless cycle of, I have this one, but that one's not available, I'll put it back down. I have this one's not available, I'll put it back down. So we'll end up starting with that.
Yeah, so we also starving, right? So we are waiting. Also, maybe there's another deadlock. Okay, so right now it's like, okay, we have a different source code. It's pretty close to the one. Okay, we talk about the odd number. So what's the next? Okay, follow up. So I already giving my left, and then I have the right. So one is like, so because this one is for this situation, because we have the P1 to P0, so we can determine maybe by the process number. Because like if I'm no matter I'm even, the one on my left or my right should be odd number, right? So we suppose it's not the same. Okay, so maybe I need to have a two different source code. Is like when I doing fork my create a new copy, create my child. So I have a code checking. Okay, if my PID, maybe my process ID is even or odd, then I will execute this thing. Okay, so just like extend from what you say, maybe okay, for odd number, I will check my left first, and then for my and even number, I will check my right first. Okay, so after this, then how can I check mine? Okay, if I'm the odd number, okay, I already grab my left fork, then how can I guarantee, or like how can I get my right? Because for the even number, like I'm an odd number, I want to get my right, and for odd number, get my right, and then for even number, right now I need to get my left. You are still trying to compete for it. And how can we make sure either one of it able to?
Could you have like, so we have the banker in the previous one, the banker was kind of supervisor of all the resources. We have like a thread on top that supervises, these are the forks we have these forks now. And make sure that they're evenly distributed.
But do we need a banker? Because for this situation, only one fork. Oh, it's like either if for left hand side or right hand side, we only one. So for banker, because I have multiple, okay. Yeah, maybe I have multiple resources, then I need a banker like help me to manage. But this one, you say they can't flat. Okay, actually, it's same idea. Okay, so maybe just either one of it, like if you remember the segmental. So that one is like I have a getting the weight signal, right? So it's the same. So who get it first, then I can grab the fork. Okay. So because I already have one, so maybe I'm checking like because it's possible that when I grab my left, you're thinking like why not we just thinking it's a round table. I just thinking, okay, so why not we're thinking two of them. Right? So I have a left and right. So right and left. Actually, they are same. Okay. So if I holding my, let's say I'm holding it and then holding it, then we'll compete for this one, right? So who get it first? Then here's the question, because it's a round table. So I have one more. So when you try to grab your left, I also, because let's say I'm odd number, I say 1, 0, 2, okay. If I, based on what I say, okay, then this is my right one. So is there a situation that I also fighting for my right? It's going to happen. So for two situations, it's okay, but for this one, then it's going to happen same time. So all of them is like it's the same idea. So if I based on the logic what we have, and so maybe we can use the flag or the key. So if you remember like the fridge, if you still remember, okay. So if you avoid like checking the milk, okay. So like if you still remember that we try to put the note, is it possible that if I didn't put the lock, it's like okay, let me put the note and then I'll go to buy the milk. Is that something when I check or like before you put the note, I check it too? And then you go back and put the note and I check, okay, it's empty. So you go to buy the milk. I also go to buy the milk. When I come back, I put the milk in and then remove the note. And then you also bring the milk back and put the milk in and remove the note. So right now you have two. Okay. So suppose we just need one. Okay. So right now we can maybe have a flag for like left and right. So who grab it, then just like holding and then take it. Okay. So here is, okay, so let's say, we always say, we do have a sequence. Then the next question, okay, for this one. If I check my left hand side first, okay. So if I win, so let me go back to that. If I'm able to get a fact, okay, so P1, I'm okay to get it. Then why now I try to get the output, okay. Maybe get my right hand side. But for P2, maybe because right now, who are you competing for? Maybe probably will be only P2. Maybe we need to set time or like you're either one of you able to win, but in like concurrently. P0, P3, P4, okay, total 5, right? Oh, okay. So is it possible that maybe I will grab but this one if we using the odd and even number to get it. So I will try to get my right. And then for we get my left. If we have 4 even number, we'll get my right. So we like this. Then do we have any problem? Let me give you a question right here because I. So for the P0, I will check my right first. I say I want to get my right. Okay. And if right here, we pick at the left. If we are like designed by the left and right. And P2, I'll check the right. Check my left hand side. P4. And then I will check my right hand side. Okay. So for the round table, like for this one, that means like, okay. For the right. For P4 is getting the P1's left. So it looks like, okay, you can complete. But concurrently, is it possible or like by the odd and even, or if we have the flat? Maybe I will having flat. Okay, have a flat. True or false? Okay. Flat. 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 So let's say I have a 2, then either one of it, I grab it. Then I change to maybe start with 2. And then if I already get it, if I change to false, then I will pick up the fault. Okay.
But what if they're trying to change the flag at the same time? Doesn't that just change the variable?
So, but it should be, if you know the atomic, you know the atomic.
No, it's an atomic instruction, so
Mhm.
they can't synchronously be.
Yeah, so it's impossible, right? So only the low end store will be atomic because we are not allowed. It's a basic fundamental to secure our action. So at least like for changing true or false, like grabbing for it, it's okay. Okay, so maybe for the flag will be like, I would say it belongs to this one, maybe the P1 change it. Okay, P1 is allowed to do it. That means I put 0 and when I check the rate, then I will check, okay, why not is false. Then I keep waiting, okay. Waiting until I able to grab it, okay. And then I would, after I grab it, then I need to check, can I get the right hand side? Okay. If I know, I need to wait until I able to grab the right, okay. With this, then is it possible that they are for this process? Okay, let's say for the P2. So here's a go back to the same question. So same question is that, okay, is it possible that I fail to grab the SS and then I get grab the SS of the left? That means I change the flag to false. Is that belongs to P2? Is it possible? If based on the odd and even.
You're saying you grab the one on your right.
Yeah, so is it possible that I didn't get the right for the P2? The flag is false. Like, can I get it before I get the left hand side?
If you check the right hand side first, then you would get it.
So is it possible that I grab it and then if I, what's the situation? Okay, so for P2, I able to grab the right hand side first. And I need to get the left, but I fail.
But you failed to get the right hand side.
Yes, yeah.
So what do? Do you wait?
Yeah,
Would you
will you
wait for
wait
that
or
left
like,
hand side,
yeah,
or would
this
you
one,
still grab the
yeah.
left hand side?
Is it any situation? Or like, is it possible going to happen like that? Okay, both for like P1, if I look at the P1 and P2, I already grab the right for my left and you get the right, and why not I commit for it? Is that okay? Okay. Incoming, does it deadlock occur? If you understood, then you can able to answer this question. Is a deadlock going to occur for this situation? Yeah, so, yeah, so if like either one of I don't care the right, if because I already get the left, right? So if I going to grab my right hand side, I will guarantee I already grab my left. So if I'm going to execute my left hand side for the P2, so also because I already grab my right hand side. Okay, so either one of it is grabbing. So no matter who is trying to fighting for it, no matter how, there should be one of
Someone is gonna get.
still get it. Okay, so some of them is like able to get it, and then after it completes, I will release it. So once, let's say if P1 grab the right hand side first, I change the flag and change it. Once I release it, then P2 I can go to grab it. Yeah, so fix. Okay. Perfect.
Well,
Okay, yeah. So, but anybody of you like still confusing, or can you get what we're doing? So when we do like the left and right. So here's the one of solution. Actually, we talk about this one. Actually, it's the one of correct solution. So like we can prevent the deadlock. So check in the left and right. And also we have others possibility. You can look at it. Let's say we have the resource the hierarchy. So we can order. So when we require the H philosopher to pick up the lower numbers for first, and then the higher numbers for. Okay, and let's say we are just like giving a number, like instead of like left and right, or like giving a 1 or 2, like which one. So for this one, we'll ensure the circular weighting condition they can be avoided, and then also prevent the deadlock. But it's like calling the color imbalance for resources allocation. These are things like, is it possible have a like imbalance? Is it possible, right? Yeah, maybe I always like grab my left, right. So then we need the thinking, and also we have one more approach. So let's say, can we have a waiter to serve? There's a way we talk about the banker, right? Okay, the banker. So this one we maybe have a waiter to control the access the fog. So they must ask the waiter to get the permission. Okay, so if we can decide, okay, if I need to have a waiter, how would you handle? Just like have pseudocode, or we don't have to think about it. So what's the good method? Like if why not I have a waiter, like how will you do? Like let's say if you are 4, you're sitting way over there, and then you have one more waiter. Okay. How can you ask for or request for resources? Of course, like you need to think about a situation is like, okay, only one process or concurrently, I have multiple processes, like 4 of you ask the waiter in the same time. Okay.
Okay. Say, well, this is already the 3rd time trying to eat, they so then we'll prioritize process to have.
Okay, so we have about or like checking the way the last frequency, like based on the frequency. Okay, you already 3 times, like 1, I need to be balanced. Okay, you already come here to ask 1. Maybe we need to keep the record checking. Okay, taking turns. Okay, it's okay. And then also we call it like asymmetric resource allocation. So we can change like odd number or like even number to pick it up. So that's when we call the likelihood or deadlock, but it was like some philosopher. Like that's what we say the running time. So maybe we need to set the timeouts. So need to like wait for the certain time. So once you pick it up, then you maybe need to wait for some time. So once you wait, maybe the one next to you can able to pick it up before you. Okay, so we're taking there's a one-up option, and then for the weighter, that's what you say. So when I come to request, and then I will keep the tables. And also we have one more, like let's say we maybe have a token-based system. So this token-based is like help the philosopher to pick up. So they can pass the token to others. Okay, so it's a taking terms. If I have a token, I can pick up left and right. Okay, if I don't have a token, I need to wait somebody. Okay, so but for this one, can lead to like better resource utilization, also less waiting time, but also we have overhead that manage the token and possible to lose the token. Okay, so when we add something more to manage, it's like, okay, is it possible? Can we lose the token? Yes. And or it's a mistake. Okay, maybe the token because we do have possible some like physical like hardware issue, right? Be it failure, or sometimes maybe other program, like if the OS like couldn't manage where we access the memory and then overwrite. So if we direct to some other like not related process, it's still possible. So far, like everything for this process, so we try to like different approach like to reduce the throughput. Okay, so they can like spend more time waiting than eating. It's possible. Or like the strategy focus on the timer or random we try to improve the throughput, but introduce like waiting time. We cannot have a solution really balanced. Like either you have to waiting long or like pick up the token, or like to be fair, introduce. There's no definite answer right here, like any possible, but depends on like which way. Maybe for certain process, we can wait for longer. Okay, then we can introduce the one we can wait and then just compete for it, or like using sleep time to increase the fairness. Okay, that's how we can do. Always have a trade-off. Just remember, like there's a definite answer. Then just try to implement. There's some exercise for you to practice, but later. But the next one, you should able to see if you remember, so maybe you forgot, we actually for our course OS we have a quiz. Okay, do you know we have a quiz? You oh no, not a quiz, it's an exam quiz. It's a QUIZ quiz, not quiz. It's a quiz. Okay, quiz. It's not quiz. Okay. So could you see the quiz? I should say available today. Or maybe I need to say it available. Okay. So let me talk about the quiz. Maybe I didn't say it with made visible. Okay. So you only have one chance to do it, but I suppose it's pretty simple. So it covers our previous two like the main two main parts. Let me open the lecture. So if you remember some basic information about the let me open it. Like what's the definition and processing and management. So nothing about the algorithm or like for the segment. Okay. So you don't have really those like complicated question. You don't have it. So just like more likely some definition information. Okay. You only have one time to do it. I set the time limit for 2 hours. That time you have 1 week to complete the stuff from today, and then I think I will close until October 21st. Okay. You can do it. And yes, there are multiple choices. Yeah. And what else the question do you know? Any questions? No. Yeah. I think it's pretty simple, like as a first quiz. Okay. So it's not that difficult and nothing tricky. Okay. Maybe not exactly on the phrase, but you can look at it. Okay. And time limit 2 hours. So but I think total 20 questions. Okay. What else? Nothing. Okay. So we will cover not including the lecture, like not including the part of for today, but before the previous week. Okay. And it should be starting. Let me open it. I think last like ending the right here, the chapter 5. Okay. And then 6. Suppose we don't have a, because there are some concept like we correlated, but I don't really ask something really related to that law. Okay, so not including the principle. Okay, so more likely some 3 weird things. Okay, pretty straightforward, simple. Okay, and that's it for today's class and the lab.